ZFS is a robust file system, and it's a great foundation to build your storage on. That's why platforms like TrueNAS and Proxmox rely on it. With ZFS, you get powerful tools to tune performance, protect your data, and design your storage around your workload, whether you're optimizing for speed, redundancy, or both. Most people stick to the basics, snapshots, redundancy, and things like that. But if you ever want to go deeper, there's a whole world of performance tuning in ZFS that opens up. Today I'm taking a closer look at one of those lesser-known features, the special metadata VDEV. It doesn't get a lot of attention, but it can make a big difference on how responsive your system feels, especially if you're using spinning disks or working with lots of small files. I'll walk through what it is, why it helps, and how to configure it in TrueNAS. And I'll show you some benchmarks I ran just to see how much of an impact it can make. Before we get into the special metadata VDEV itself, it helps to zoom out and look at how ZFS organizes storage. At the core of every ZFS pool is something called a VDEV, or short for virtual device. You can think of a VDEV as a building block. It's a group of one or more physical drives that ZFS uses to store and manage data. When you create a pool, you're actually building it out of one or more of these VDEVs. There are a few different types, each with their own job. Data VDEVs hold the actual files and form the foundation of the pool. Log VDEVs help speed up sync writes, and this is where slog devices come in. Cache VDEVs act as read caches. These are your L2 ARC drives. And then there's the special metadata VDEV, which is what we're focusing on here today. The special VDEV in ZFS is designed to store metadata, things like file names, permissions, and timestamps that help the system track where your data lives. It can also optionally store small files, depending on the threshold you set. On spinning disks, accessing metadata can be slow, especially if the drives are already busy with regular file I/O. Moving this special VDEV to faster storage also ties into a bigger plan that I have for my NAS, which is building a hybrid pool. Now, I'm not creating separate SSDs and spinning disk pools. Instead, I want to combine them into a single pool that gives me SSD-like responsiveness while still handling the capacity of spinning disks. Kind of like those old hybrid drives you used to see, but actually good and scalable. So let's take a closer look at what the metadata VDEV actually is and how moving it to faster storage helps. So back on our dashboard, from here I go into storage, and here we'll want to create a pool. You can see I have some unused disks that just popped up. So let's create our pool. What am I going to name this pool? I'm going to name it Pond because it's pretty small. And the disk layout, I'm going to make it a mirror. So it's just going to be a mirror, 2 disks. And so choose my disk size. I'm going to choose 2 of those 14 terabyte Exos drives. And it already picked for me a width of 2 and 1 VDEV. So that's our data VDEV right there. If we wanted to add a log or a slog drive, we would do it here. I'm not going to do it because that's not part of this video. I have a video on that. But what we want to do is go into the metadata section. Once we get to metadata, we can choose a layout. I'm going to choose mirror, and then I get to choose which disk I want. I have a pair of SSDs, and then I have 1 NVMe in here. I'm going to choose my pair of SSDs, and it automatically said, okay, a width of 2 and 1 VDEV. So that will actually create my special VDEV for my pool. Now, it's really important to mention that you should at least have a mirror. If you lose this VDEV, you lose all of your data. So it's really important that you have a lot of redundancy on here, probably more than you think you should need. 3-way mirror or mirrored pairs. But you want to protect this. You want to make sure that it stays alive, because if it goes away, your data goes away and you can't access your data. Think about if you had a map of all of your files and all the attributes about those files. Well, if that map goes away, you have no way to point to those files or get information about those files, even though they still live on disk. And so originally, when you create a pool, the metadata lives on the pool you create. So it has the same redundancy as the pool itself. What we're doing is we're going to move it off the pool to get some better performance, but we still want to make sure that we make it redundant. So here I'm just choosing a width of 2. Next, and really we can skip all the way down to the bottom, and we can say create pool. It's going to wipe my disks, and then it's going to create this. And so once we have this pool, you can see my pool called Pond. It has a data VDEV, so 1 mirror, and it has a metadata VDEV, so 1 mirror. If we go in here and visualize it, you can see here's my mirror, and this is the 1 VDEV mirror with 2 drives in it, and that's the 14 terabyte drives. And then you could see my one mirror of my special VDEV or metadata, and it has the 2 drives. And really from the UI, that's all you need to do. Now, if you want to change or set the small block values for this pool, we're going to have to do that in the CLI. So let's hop in the terminal really quick and do that. So in our terminal, we're going to do a zpool list and use pond, and we're going to search for this special line. And if we do it, we could see right here, here's my special VDEV for the pond pool. And you could see it is 472 gigs and only 504 kilobytes are used. And actually, I think it's a little bit easier if you just do a zpool list and you say pond, and you could see more information about this. So it's using 504 kilobytes. It must have some tiny little metadata written on there now. Other than that, everything's free for us to use, both for metadata and for our small blocks or our small files. And if we want to see what the small block value is set to for this new pool that we just created, we can do a ZFS get special underscore small underscore blocks, and then the name of the pool, and then -R, and that will list it out, and it's set to 0. And so if we wanted to set it to something sensible like 128K, we would just do a ZFS set special small block equals 128K, and then the name of the pool, which is pond. And that should set it right there. And that's going to set it at the parent level. And so all data sets will now inherit that. You could do it at the data set level. I think it's just a pond slash, the data set name. I don't have any other data sets. And that would set it at the data set level. But we're going to set it at the pool level. And then if we do a get again, we should see that it's set now to 128K. So this means now that any file that we add to this pool, instead of landing on the spinning disk, the 14 terabyte drives, it's going to land on this special VDEV pool, which is a pair of SSDs. So I'm actually going to go into that pool right here, and I'm going to mkdir test 1, and then let's cd into here. And what I'm going to do is just really quickly just create a bunch of test files and just show you that when we create these, they're actually getting set on that special VDEV and not on the disk itself. So I have this command right here that's going to create 10,000 files, 10,000 4K files, and put them in this folder. And at the same time, I'm going to open up my special VDEV, and I'm doing a watch on my zpool, and I'm filtering just on that one called pond. And what we should see when we do this is the special VDEV allocation here should start to increase, while we should see the allocation on pond, I think, pretty much stay the same, because if this works, it's going to put all of these files on this special VDEV because the block size of 4K is smaller than 128K, which we set. So let's run this and keep your eye on the right side. There we go. We see it going up. See it going up. See it going up. And you can see here that we have 0 right here on mirror 0, but on mirror 1, the special VDEV, we have 5.25 megabytes. And for the pool as a whole, we have 5.24 megabytes. Now it's counting these together, but you could see that all of the files went to the special VDEV because they were all under 4K. So now if we create or copy files to that pool and they're less than 128K, they're all going to land on this special VDEV, and then we'll have fast access to them. Now that everything's configured, I wanted to see how much of a difference the special metadata VDEV actually makes, not just in theory, but in real use. To test it, I built 2 versions of the same basic pool. Both use a single spinning disk, a 14 terabyte Exos drive, no cache, no slog, and no extra tuning. On the second version, I added a Samsung 990 Pro NVMe as the special VDEV. Nothing else changed. The goal was to isolate the impact of that one feature so that any performance gains would come from the special VDEV alone. The script runs a set of lightweight real-world tasks, listing directories, creating and deleting lots of small files, measuring small blocks read and write times, and simulating small workloads. It's not perfect, but it gave me a consistent way to compare how each pool actually feels under light and moderate use. Now, I'll have the script linked below if you want to try to tweak it on your own or fix it. It'll be down in the description below. Let's start with the 4K random read test. With just one spinning disk, the pool hit around 4,300 IOPS. But once we added the NVMe special VDEV, that jumped to over 57,000. Now that's more than a 13-time increase. Also, latency dropped from 866 microseconds to just 66, and that's where the difference really shows up. This kind of improvement is the one that you feel when you're browsing directories or launching containers. The system just reacts faster. Next up was a mixed workload, random reads and writes combined. Now this boost wasn't as huge, but still meaningful, about 25% more IOPS, and latency improved by about 20%. This is closer to everyday activity, things like editing files, running background services, running containers, or logging. The system all around would feel much quicker, and again, the special VDEV is what makes this noticeable impact. Now with the pure random writes, the gains were more modest. I saw about 9% improvement in throughput and about 9% drop in average latency. Not huge, but a step in the right direction, especially if you're aiming for more consistent performance. The real story here was the maximum latency. That dropped by nearly 40%. This means fewer spikes, fewer stalls, and a smoother overall experience. The ZFS stats backed it up too, and some of the writes are now going to the NVMe, which offloads the pressure from the spinning disks. That's exactly what I was hoping to see from the special VDEV. Then I ran a test focused specifically on metadata, things like file lookups and attribute checks. With the special VDEV in place, the pool completed about 9% faster. Now, this isn't a huge number, but it was consistent, and this kind of work happens quietly in the background all the time, so even a small gain here can really add up over time. And finally, the big one, sequential metadata performance. This is like running ls, lr across a large directory tree. With the special VDEV, that test finished over 70% faster. That's huge. When ZFS can pull metadata from a fast NVMe drive instead of hunting around on a spinning disk, the difference is instantly noticeable. Now, these tests were designed to show best case performance for my special VDEV, but I also did my best to minimize the impact of the ARC and other caching layers just to keep things consistent and repeatable. In a real-world setup with RAM, ARC, and actual workloads running, you might even see better results than what I've shown here. Now, this wasn't meant to be a full synthetic stress test. It's more of a practical look at what a special VDEV could do, and if you're running spinning disks and care about responsiveness, this could be one of those features that really level up your NAS. Also, I'm not claiming to be a ZFS expert. I'm just curious about what these features actually do and how we can use them to make our systems even better. If I've got something wrong or you've done your own testing with special VDEVs, let me know in the comments. I'd love to hear what kind of results you've seen. If this was helpful, feel free to give it a like or subscribe if you want to follow along. I'll be upgrading parts of this NAS soon, and I've got more advanced ZFS topics coming up. And if you're interested in other VDEV types like slog or L2 ARC, I've covered those in other videos, so check those out if you're working on building a faster, more responsive system. I'm Tim. Thanks for watching.